name is Ilya Benish, and I'm a building analyst with the Cold Climate Housing Research Center here in Fairbanks, Alaska, Climate Zone 8. And what we have going on today is we are going to cover a basic vapor retarder install on the walls and ceiling of a house under construction. And over the years, we've covered specific details involving vapor retarders because vapor retarders, which are also our air barriers, are such an integral part of construction in Alaska. And we've never covered a start to finish how to basic install video. And if you don't get the basics right, it can be very consequential. In this video, I'm going to cover methods that have worked for me for a single person, a single laborer doing a mid to large size space. It's by no means the only way to do this, but these are methods that have worked for me. So follow along as we get started. The first thing I always do is I look at the entire project. I want to make sure that all the framing is done, and especially all the framing that I need in place has been completed. So right here on the gable end, I've got a nailer, so I've got something to attach my vapor retarder to on the perimeter. So making sure all the blocking and support for the vapor retarder is in place. The other thing is it's really common to find nails like this poking through the ceiling or other places that will interfere with the vapor retarder. And the last thing you want to do if you're working alone is be holding up a 20-foot sheet and suddenly you get into this nail and you have to stop everything, turn the ladder around, potentially get into a mess with your sealant, pull this nail out, start over. In addition to inspecting all of the walls and the ceiling to make sure I've got good support for my vapor retarder and that there's no other fasteners or anything like that that could interfere with installing the vapor retarder, I'll also go along and I'll check for issues with workmanship with the insulation. This is the last time to fix the insulation before it's covered up effectively forever. So we want to ensure we're getting maximum performance out of our install. When I get ready to install my polyethylene sheeting, I will sweep the entire floor once. I don't care how clean it looks. There can be a lot of dust left over from the construction processes on the subfloor. And if too much of that gets on the polyethylene sheeting, it will affect how well I can bond that plastic to itself, or I can seal to the subfloor if there's too much dust there. And this right here is a critical spot where the bottom plate meets the subfloor, because I have to be able to apply acoustical sealant right along the subfloor here. If there's too much dust, it won't bond properly. Also, before I apply my plastic, I'm going along and I'm going to shoot foam right here in the joint to air seal any gaps where the plate meets the subfloor. Once again, I don't want any dust in there to interfere with my insulating. In addition to spraying foam under the sill plate, if I see gaps in the corners here where the studs or the stud and the nailer meet, like in this case there was a 1/4 inch gap, I will also fill this gap with foam. These corners, based on their exposure and the fact that there's a lot of framing lumber here and less insulation, they just tend to run cold, so they can use all the help they can get. And this is actually some substantial air sealing that we're doing here. Now that we've completed our visual inspection and our prep work and any additional repairs and fixes to the insulation, we're getting ready to roll out our plastic sheeting. And I'll often get asked, what should you do first, walls or ceiling? And there's no hard, fast rules to this. It's usually dictated by the job. In our case, and in many cases, the goal is to get the building to hold heat as quickly as possible, so the vapor retarder goes on the ceiling first. More importantly is that I'm not going to bring out the acoustical sealant and do any sealing until all the plastic is up. I found that it's a lot less messy and actually more time efficient for me just to concentrate on the plastic, get all the plastic done on the ceiling or the walls if I'm doing the walls first, then go back and apply the acoustical sealant. With every new vapor retarder job, I start with a new utility knife blade. It pays dividends to be able to cut this plastic cleanly, especially if you're somewhere up high reaching out and you don't have a lot of leverage. then being able to make a clean cut easily and safely starts to matter. I have a couple of pointers for installing the poly sheeting on ceilings. I always try to start with one of the longest edges first, because if you start with one of the longest edges first and get that started nice and straight, then it's more likely to be flat across the entirety of the ceiling. In this case, our room is square, so it matters less what side I start from, except for the fact that there's a stair hole over there. And the poly that I'm working with is 20 feet wide, so I'm going to start at my far wall so that my seam is over here, not directly over that stair hole. I usually like to start by running about an extra foot up the wall. If I'm not sure how square something is, I might go more than a foot. It's way cheaper to use a few extra inches of plastic as spare than to reach the other end and have run out. I have to start with the plastic being straight right here at the edge of the ceiling. And what I'm using is this line created where my double top plate meets the roof. And what I'm using there is I'm using the factory edge that came with our polyethylene sheeting, and I can do two things. I can either mark in, let's say 6 inches with a marker, and start with that marker right here where the wall and the ceiling meet. Or if I get lucky, I'll have a factory crease, and those are also pretty darn straight to the factory edge, and I can just line my factory crease up right here with the line where my top plate, my double top plate, meets my ceiling. I'm going to start by using my factory crease as a guide. I'm going to put it up here in the corner, and I'm going to run my plastic by eye about 6 inches further to the left, so we have enough plastic overhanging here. And then I'm going to staple, I'd say 3 to 4 staples in right here close to this corner, within a couple inches. Then I'm going to go mid-wall, 12 feet down. I'm again going to line that crease up right where the wall meets the ceiling. I'm going to put 3 or 4 more staples in, a couple inches away, and then I'm going to go to the far corner and pull my plastic tight and do the same thing and run 3 or 4 more staples in. What that gives me is the sheet is now hanging in 3 places, and I can get a good look at it and make sure it's nice and straight. If I have to pop some staples and make some adjustments, I can do so. For this job, what I've got is hand staplers. These are your classic Arrow T50 staplers. And for putting poly up, I like to use 3/8 staples or 5/16. Anything shorter than 5/16 and the poly tends to fall off. There's not enough holding power in the staple. And if you go bigger than, say, 3/8, and what I've got here is a 1/2 inch staple, you know, remember, I'm doing this overhead. I don't have the force, and the stapler doesn't have the force to bury those 1/2 inch staples. You can see there's about 1/8 of an inch proud there. When I run in my 3/8 staple, that's acceptably flush right there. And if I run in my short staple, we'll put one all the way over here. This is a 1/4 inch staple. You know, I couldn't get them to do it, but they sometimes will just pull right out. And a lot of it depends on the piece of wood you're going in. General rule, stick with about a 3/8 to a 5/16 staple. Right now, my plastic is only held up in the 3 spots. There's 4 staples holding it in the corner. I pulled it tight, lined my crease up where double top plate and ceiling meet in the middle, pulled it tight, put in 4 staples, and did the same thing at the far corner. Now, I'm going to get back under the plastic, and I'm going to go to the middle between my existing staple points, and I'm going to staple here and the same thing down there. If that looks nice and good, which I assume it will, then I can go along and staple 2 foot on center, and that will give me a nice starting point for my plastic to go out into the ceiling. Now that my plastic is securely anchored straight along my starting line with staples every 2 feet, I'm going to start in the middle and push out into the field. And I'll probably go out about 4 to 6 feet and run a couple staples, work my way sideways a couple of feet, and then just keep pushing out in the middle and working my way out sideways. The mistake people make is they have a straight line, but they start at the far end. And when you do that, it's too easy to introduce wrinkles by the time you get over here to this side. It's far better to start in the center and make a triangle and push out and work to the sides. You'll end up getting better results. When I'm rolling out my sheeting, I eyeball it square to the walls, and I can follow the lines that are on the subfloor to keep my sheeting rolled pretty much perpendicular to the walls. And then when it's time to cut it, I'm more likely to get a nice square cut, and I can see my lines in the floor as a visual reference, and I can also check for square here on the sheet. Like that. Leaving a nice square edge for the next sheet or the next guy. It's just good practice. When I have overlaps and seams in ceilings, this vapor retarder is doing such an important job here, and the plastic sheeting is cheap. I think it's good practice to overlap by 1 full truss. In this case, that's 2 feet. So when I'm cutting my plastic, I'm taking into account that I have enough plastic to be able to reach over to this second truss. I think that makes for a very durable, clamped, long-term connection. Now I'm getting ready to put up my second sheet, and we have cut this wide enough to give ourselves a foot of overlap, and that also lines us up right here with a factory crease on the sheet. And this factory crease, just like on the other side, we can put it right in here at the joint of the wall and the nailer plate. As an aside, I'd like to point out that when I'm doing vapor retarders on ceilings, I like to use, for a 9-foot or an 8-foot ceiling, I like to use either a 5-foot or a 6-foot step ladder, because I can move it around really fast, but I can also stand safely above the ladder and reach a lot more than if I was using an 8-foot ladder, which would ultimately end up getting in the way and be more difficult to move around. It's all about efficiency. We're now at the spot where our 2 sheets of plastic overlap at the ceiling, and we've got our 2 feet of overlap. So there's plastic going to be lapping over 2 trusses here. And this here is where we're going to be running the acoustical sealant on this truss. And I want this plastic to be nice and tight to the truss, so I've run my staples a little closer. Normally my staples run about every 2 feet or so on center, but here, because we want that acoustical sealant to run down nice and flat, I've run my staples closer. The next thing I'm going to do is I'm going to pull my plastic over and just barely catch this truss and run a staple in, but stretch it tight. And I'm going to do that in about 3 or 4 spots, just enough so that the plastic is hanging here, but it's nice and taut. And that means that I can run my acoustical sealant down the truss, and it's really easy to bed this overlapping sheet in that sealant without making a big mess. We are now ready to start sealing the acoustical sealant on the ceiling. And in Alaska, in all of our municipalities, Tremco acoustical sealant is still what we recommend for sealing the seams in poly. Red tape is not equivalent to Tremco. It simply lacks the ability to provide consistently a good air seal, and that can be because wrinkles get in the tape. from it not being installed properly. It could be due to adhesion problems. Tremco works great pretty much under all conditions. When it gets cold, it will extrude a lot more slowly out of the gun. So keep your tubes warm if you're working in a cold environment. Put them you know, in a heated space. Lesson is, don't put the Tremco tubes in the vent of your truck heater, because a very sad thing will happen and your truck will never ever be the same. Other than that, I always wear disposable gloves when working with Tremco. It does get everywhere and it's difficult to remove. I'm going to start running my bead of sealant at one end here and then all the way across the truss. I'm using a caulking gun that's got a pressure relief, so as soon as I'm done, I can hit the pressure relief. I don't keep extruding Tremco out of the tube. Most importantly, the golden rule of air sealing with Tremco and poly in wood frame construction is your joint must have solid backing. So we have planned our poly layout here so that the overlap happens all the way on this truss. It's continuous. The most common mistake I see is people randomly trying to seal the poly. They'll do it out here in the field along the length, or they'll cross the trusses and overlap the poly and think that's adequate. It doesn't work. You have to have a clamped seal. So when your drywall goes on here, this is a clamped, fully supported joint. It won't come apart over time. If you do that sealing out here in the field, you will have an air leakage problem eventually. Keep backing on your joints. The tape I'm using in this case is 3M 8087 cold weather seaming tape. It is rated for adhesion to polyethylene sheeting, and this is a great application for it because tears in the poly are inevitable. You might get a staple that's hanging loose that you have to pull out, or there's some other damage, and so it's really nice for patching holes. And you just have to make sure, because it's pressure sensitive, you just have to make sure you get really good adhesion, and that'll make a nice patch. But the other place that you may want to consider using the red tape is to support and keep this seam right here held up. And I'm not just demonstrating it. I'm not doing this for air sealing purposes, but if you have any concerns at all that the drywallers might catch this plastic edge when they're running their drywall on here, this tape will hold the plastic up and keep it from pulling loose when the drywallers are at work. Here's a nice example of a wrinkle, and wrinkles are just a fact of life. In spite of our best efforts, we will get those sometimes, and this is another reason for having a nice fat, like a 3/8 bead of acoustical sealant, because there's enough acoustical sealant there that you can take a small wrinkle and you just pinch it together and then fold it over like that, and you can run a staple right over that wrinkle and you've still got a continuous seal. There's enough sealant here that it all stays together. We're just about ready to install the poly on this wall. The last little bit of prep work I'm doing is I'm securing the ceiling poly where it laps down our wall. We don't want a concavity like you see right here. You can see it flexing when I push on it. We want that poly nice and tight in this corner where the nailer and the double top plate meet. So I'm not only stapling into the truss, I'm also pushing up on the poly and stapling in the double top plate. That gives me a nice corner here with plenty of slack. If we leave that concavity there, there's a real risk that the drywall will stress that poly and eventually tear it because it's not tight in the corner. We're now getting ready to install the poly on the wall. The first step is cutting the poly and figuring out how long to cut it. A cautionary tale: don't try to do 2 walls at once and change plane. I just typically do 1 wall at a time. It's a unicorn if you think you can turn the corner, especially on a big wall, and do a whole nother section. The wrinkles just tend to happen. When I look at this wall, I see a stud right here. And so what I'm going to do is cut my poly that's going on here, maybe 4 to 6 inches long going this way. And then when I cut the poly for this wall, I'm going to make sure it's long enough to overlap on this stud. That way, I've got 2 points of connection for my overlaps. It makes for a very robust joint here in the corner. We're now just about ready to install our wall poly. And once again, we've got our factory edge facing up where we can work with it. And conveniently in this case, there's actually a factory crease in the poly about 2 inches down from the factory edge. If this wasn't here, this is my personal preference, I'd still put a mark here with a marker and install my wall poly so it laps up the wall and goes onto the ceiling just a little bit. I like that extra bit of reinforcement, and I like having extra poly above my acoustical sealant joint here, just because it can get messy and it's difficult to be completely accurate in hanging your poly perfectly straight right along this edge. So, like I said, my preference is a little bit of overlap. Otherwise, the process of hanging wall poly is essentially the same. I still pick 3 points and hang my poly. It's nice because now gravity is working for me, and the sheets will tend to lay out nice and flat right away. Point of note, when I'm stapling my poly on, I'm stapling into the top plate, not the double top plate. That way I can always pull this back and I've got unobstructed place to run my acoustical sealant. When I get close to my window openings, I do the same thing I do at the top of a wall, and I hold my staple back. Here I've got, a king stud and 2 trimmers. So I'll hold my staple back 3 inches so that later when I cut the window poly out, I can get my acoustical sealant inside here and get a really good seal directly around the edge of the window without having to fight the plastic and the staples. For years here in Alaska, there's been a school of thought that says you should wrap your poly into the window opening and then seal it at some point with acoustical sealant here and tape it to the framing. And I'm not a big one for it. What we're trying to stop here is air leakage. Diffusion, the vapor retarder acting as a diffusion barrier through the framing, is far less concerning than the air leakage that you find here where the rough jambs come together. The other thing is, this builds up when you start wrapping poly and adding tape, and when the drywall installers come by and cut the windows out with their rotosips, a lot of the times they'll just tear this right up, and then it's very difficult to fix. So I think it's far more effective to take a high quality caulking, weather caulking with good adhesion to wood, and you fill in, and this is all for air sealing purposes, you fill in this joint right here at the jamb, and you turn the corner, the thickness of the jamb 1.5 inches, and you tool that caulking. And now, depending on what this caulking is that you're using, it may need some time to cure. But now I've got a really good air seal when I add my Tremco here, because this is all now solid wood. There's no more joint where the jambs come together. One more thing, this is not a how to weatherproof a windowsill video. This is an air sealing video. So depending on where you are, climate-wise, it could be interior Alaska's desert climate, it could be Alaska's coastal climate. All of the other details that need to take place in here may be radically different. But in all cases, air sealing this jamb and transitioning to your vapor retarder effectively is what matters. When I apply the acoustical sealant, I have 1.5 inches of solid wood to work with, and I try to hold the acoustical sealant as far away from the window edge as I possibly can. But sometimes you'll get some squeeze out and that Tremco will get into the window edge, And that doesn't make anybody else that has to work on the window very happy. So if you see that happening, this is another great place for red tape. I've got some 2-inch red tape right here. And I literally split that tape by eye right on here. And so as long as this doesn't interfere with anybody's weather sealing work, it protects all the other workers from any acoustical sealant that may have squeezed out. It's just a cheap insurance for goodwill. When I seal the top of the wall vapor retarder to the ceiling vapor retarder, I run the acoustical sealant right along the face of the double top plate here. And I start it at the one edge. I've carefully pre-folded my corner so it's not all bunched up. But I start right where the wall vapor retarder ends, around the corner, and then just run a nice 3/8 bead of sealant all the way across that double top plate. And ultimately, that bead of sealant goes all the way around the ring. Just like sealing the wall vapor retarder at the top of the wall, I'll pre-fold my corners. In this case, I've taped my wall poly up to keep it out of the way, and I've just run a starting bead, but I'm going to run all the way here. And the key to doing this is to apply your acoustical sealant directly to the subfloor where it meets the bottom plate. People want to seal along the bottom plate, but that does not air seal the joint where the bottom plate meets the subfloor. Your 3/8 bead of acoustical sealant needs to be right here, and the poly needs to be bedded on the subfloor. We've now completed the installation process of a 6mm polyethylene vapor retarder on a ceiling and an exterior wall, as well as that transition, that critical transition from the ceiling to the wall. And in this video, I'd say one of the biggest takeaways is you've got to pre-plan and know where you're going to have your vapor retarder overlaps and where you're going to be sealing your polyethylene. And that must be solid backing, whether it's the subfloor or the top plate or a truss or a stud. You must have solid backing to ensure a good long-term air seal. And the methods I've shown here, I've developed working largely alone with really big sheets. And so hopefully some of the tips and tricks here will be useful to other people working alone. In the description, we will provide more information on vapor retarders, as well as video links that go into greater depth on the process. As always, thanks for watching. Natures to know what's going on, because you're trained to do that. That's right. Just watching and waiting. That's what